Lens equation time. So last video we looked at ray diagrams for lenses, how to use those to figure out properties of lenses and their images that they make. Now we want the mathematical side of that. So remind us what our ray diagrams looked like. We had one ray that passed parallel to the principal axis that then refracts through the focal point on the far side. We had the purple ray that passes the focal point on the near side and it refracts parallel to the principal axis. This ray through the center passes through unchanged and we form an image. This one happens to be a real image. Now, we want to look at equations. So we need to define some things. Object distance here is SO, that's the distance from the object to the thin lens. SI is the image distance, that's the distance from the candle to the thin lens. Lowercase f is the focal length, which is the distance from the focal point to the lens. Object height HO is here, image height HI is there. Reminder that lenses are doing the same thing with refraction that spherical mirrors did with reflection. Same things are happening, just a different physics phenomenon. But we get to use the same equation as a result. All of the geometry is the same. So we're not going to go through a derivation. We're just going to get to say the mirror equation is also the lens equation. Isn't that great? A little asterisk on that, though. We get to use this equation if we know the proper sign conventions. When do I make my object and image distances positive and negative? When is my focal length positive? When is my focal length negative? So we need to know some sign conventions. But once we know those, we are set to use the same equation. So what are those sign conventions? Here they are in a table. This is the quantity in the first column. This tells you when that quantity is positive, the middle column does, and the right column tells you when the quantity is negative. So the focal length lowercase f is positive for a converging lens and it's negative for a diverging lens. Your image distance is positive when we make a real image, and the image distance is negative when we make a virtual image. The object distance is positive when you have a real object, and negative when you have a virtual object. You pretty much never have a virtual object in a one lens configuration, but sometimes you do with multiple lenses because the virtual image of one lens becomes the object of your second lens. And last but not least here, your magnification, which is the ratio of your image height to your object height. It's also the ratio of your image distance to the object distance with the opposite sign using these sign conventions. All I have to say is your magnification is positive when your image is upright, and it's negative when your image is inverted. So I think that does it for the equation. Same equation, new conventions, learn them. All right, folks, that's it for this video.